Hello everyone, welcome back to channel. So today's problem is level 2 problem, a little medium but not exactly very complex. And this problem or this pattern is very popular in all these FAANG, Google, Amazon interviews and all. So the problem is you have to find the longest repeating character replacement. So in this you have been given a string S, and which consists only uppercase English letters, and you have an integer k. So integer k is given, it means that you can perform at most k operations. So whenever you get such questions, right, it's very important to understand the wordings given, like whether it's at most, whether it's at least, at par, all those things, right? So you can perform at most k, so it means less than equal to k operations you can do. In each operation you can replace any character in the string with any other uppercase letter, and you have to get the continuous string of the same letters. So find the length of the longest substring that can be made of all same characters after performing at most k replacements. So very easy of this is, for example, you have a string given like this and you have k equal to 1. So here if you do one operation, you can replace b with a, and you will have a longest substring of 4 a's. So similarly like this is the input and output. So this covers our core sliding window logic, and so it also introduces an important trick like tracking the max frequency. I'm building on the previous problem that we had, so it will be easier to look at the code. And yeah, so you don't have to so you have to avoid shrinking unnecessarily. And more thing is that it is you have many problems like find the distinctive k patterns or k numbers. So if you know this problem solution, you can build on those problems also. So what mostly I have seen in interviews is that many candidates fail when they try to recompute the max frequency every time, and they overshrink the window. So yeah, these two things keep in mind, and this is a problem that we'll see in the code. So yeah, in the next video, so this is a level 2 I told. In the next video I will give insight on minimum window substring problem. So this will help you master the dynamic constraints. It will have window plus hash map concept. We have not touched the hash map concept yet. We have only touched the set theory as well as the string manipulations. And level 4 is related to why I have written the Google level, because many of the FAANG and FAANG companies that everybody wants to get into, few of this is a set standard that if you're part of this. So in this you have the sliding window maximum, and this DQ concept we will be using Q. So you hash map and few Q concepts, and will be covered in the upcoming videos. But here we are going to see our final video in the variable window shrinking pattern, and after that we'll change the pattern. Let's go here. Okay, and so yeah, so here the sliding window becomes little smart. It's just not mechanical. Windows expands normally, but shrinking depends upon window size minus max frequency. So as I told you, you can only do k operations, and it should be less than equal to k. If that is not working, then window it's an invalid operation. So we don't decrease the max frequency when shrinking, and that's the trick, because even if that's outdated, it will not break the correctness, and also it will help you maintain this complexity. Why this is like this, I will also show in little bit in code, but put your own logs and check. As this is a final problem, I haven't put any logs here, but whole this I have made ready. So let's see how this works. So you have a function of a character replacement. It takes a string and a k number. Okay, so for example here 1, and this is the string. So we have certain variables which say from the left side, let's make it the pointer 0, max frequency is 0, and we have a map. So this is a record which takes a string and a string record set and a max length. Now what is happening, we are looping over this for. So for this problem there is only one for loop, okay, and you start with your right pointer till it's less than the length, not equal to, less than. These few things are very important, why I always tell that whether you have to put less than, equal to or not. Any such small mistake, maybe your code will be completely correct but give you incorrect answer. So you take from the from the string set, you are taking the character and you are mapping the frequency of this character. So here if you see, we have a or. If or 0, then we plus 1. Okay, now what we are going to do, we are going to track the max frequency in current window. Okay, so we have this which we have put 0 and we have got the frequency of this character. So when we do this logic here, right, for example, yeah, let's come here, then it's easy to visualize. For example, this is the string, right was 0 in beginning, character is a, window has a, the frequency map is, it's a record set, right, if we say string and number. So this has value a and 1, so it's a valid thing. Why? Because it's less than 1, correct. Then we went to next one. So a, 2 a's we got from here, a got to 2, we have written here action valid because we are just building here. Similarly 2, 3. Now what window we got? A B A, A B A. Okay, and changes which we need is, so if you see here, 4 minus 3, which is like this, and because of this our step 2, it becomes invalid. Okay, now we move. So here max frequency 5 minus 3 equal to 2 we are getting. Next one, a b, a, this b we are picking, and we have a character b. I will do just little tilt to this here, and little to here. So you have right here 4 and character b, window is a b, max 5 minus 3 equal to 2, which is not equal. Okay, so too many replacements are needed here where the catch is. Now you need to know where to shrink. So once you got this thing, it means you have to shrink your window, and then we start the step 3. So we remove from left. Always in these window patterns we have always removed from the left. So the new window is AB. Now size is 4, max frequency is 3. We are not recomputing right now, that also I have written here. Put your logs and check how we are not recomputing, but from this here we are here. Now 4 minus 3 equal to 1, which is less than equal to our k value. So these my number of operations we were supposed to do. What we did first, we tried to add everything, then we realized, oh, we are at a wrong step, we have to shrink. Then we started shrinking. So once we shrink the window, here we don't know how much we have to shrink, but when we shrink we realize that are we part of this frequency or not? Yes. So once operation we have done. Fifth, we got the window like B, we shrinked again. Sixth A, we continue. So the final answer was max length equal to 4, and what we got, one operation we did, 1 2 3 4, 4 A's we got in a continuous line. So this is how this pattern grows, and it's very important that you do not decrease the max frequency when you shrink. That is the main trick. So I have written here also, and because unnecessarily decreasing the frequency, it may break the correctness, and that is also the main trick behind this pattern. Okay, so with this we cover our variable sliding window level 2 problems, and next we will do this problem. So see you in next video, and if you like the channel, do subscribe. Thank you.